Hello, good day. So for today's lecture, we are going to proceed with the new topics, which is the morphological in digital image. Okay. So this is related on the binary image anomaly that we are going to have the examples on the process, right? So let's look at the terms of morphological. If you look at the based on the biology studies, right? Morphology is about the study of the forms of things like shape and structure of living things from biological perspective. But in mathematical terms, where we're going to use in image processing, right? So this is a tool to extract the image components useful in representing region, shape, and boundaries. All right. So in morphological methods, it will include the filtering process, thinning, and pruning, and based on set theory. So this is set theory. This is a theory related to the when you learn in your secondary school, you're going to learn back about the sets. Okay, the theory of the sets. So all the morphological functions are defined for binary images. So we are going to work with the binary images here, but most have natural extension to graphical images, and we are not going to look at that. So these operations are performed using the concepts of reflections and translation. So this is just a mathematical equations. So we just need to look at how it was performed. Uh, then you can see the results of the output. All right. Okay, so the morphological operations definition. So what is morphological operations? So this process is actually defined in terms of sets. So the equations of mathematics will be based on sets. So sets is related to the uh, for example, I will show you this. This is a set theory. So I'm going to go back for this one. So we are going to look at the image processing, right? So we are going to use two types sets of pixels. All right. So they are calling two types of pixel. One, they have the objects here. These are the calls objects. And the second one, they call structuring elements, where I'm going to simplify it as SE over here. Right. So this is represented as set, and this is also represented as set. So if you're going to the right directions over here, at the end in digital image, it will be based on the pixels here. Same goes to the structures elements over here, right? So in these morphological operations, right, there are two big main process that we're going to learn. The first one, they call it the erosion process, and the second one is the dilation process. If you look at it, this is this input image, right? This is normal image here. So when you erode the image, right, you can see that the words here is getting thinner, whereas when you do the dilation process, you can see that the words is getting thicker. So this is related to the erosion dilation based on the morphological operations. So this is the example. You have the input image of your object over here, then you have the structuring element, and these two will do the process here, scanning from here till the end, right? And then you are going to get the final object. For example, in this particular object, the output image will be only this one, which is going to be a thinner, which is called erosion. So this is the big one, and then later you have the structuring element over here, and then you have the result, this smaller or thinner versions of the output image, right? Sorry, for the result image, for the input. Okay, so this is just the basic concept of the set theory. If you go back to your secondary school, right, this is all the related, all the what I call the symbols that we are going to use. So this is about the union, the intersection, or this one. So you are going to get a two uh, sets over here. Okay, for example, a set is specified by the elements between two braces. If you are going to have two sets, right, you're going to put inside here. Okay, the elements of the sets are the coordinates x, y, are the pixels representing objects or other features in an image. All right. Given that A is a set in Z2 is the actually the semester the universal set into the image, right? So you are going to look at the what I call the symbols of all the unions and the interactions between these two sets. Okay, so you have to read this one, and then I think you're going to learn remember back the past theory on the sets itself. All right, so just go through this one. What is the complement, the difference? So you have, this is the mathematical, how you're going to write in the mathematical form, right? So this is actually what is complement, what is differences, and you can see that this is how it works for the two sets, all right? So this is just the rules for this one, all right? And we go through this one, the same one. So you have the reflection and you have the translation. So this is just the mathematics presentations of the process of the operations itself. All right. Okay. Now we are going to learn about the SE. So just now we know that from the morphological operation, right, you have two sets. One, they have the objects, and the second one they call it structuring elements. Okay, so what is structuring elements here? So it is an essential part of the morphological dilation and erosion operation. So these will be used for the process of dilation and erosion for this particular structuring element. All right, this is going to be used on the image itself. All right, so a structuring element is a matrix that identifies the pixels in the image being processed and defines the neighborhood used in the processing of each pixels. So you can see this is an example of the structuring element we can use, or you guys normally going to be to use in the class over here. So we have the this type over here, we have the box type, we have the circle type. So the dot here is denote the origin of the SE, the structuring elements here. So if you want to rotate, so this is going to be the origin. If you want to turn this one, so this is going to be the origin, right? So normally, for example, this is just another example of FSC, right? So this will be the shape of the SE. So if you have this one, you will be this one is a black one. So if there's no numbers, this just don't care. So you're going to look at this is just example of the SE that we have, right? Okay, when you're going to use the SE, the structural element, right, there are three terms that you need to understand. Okay, the first term they call it fit, the second term they call it hit, and the last term they call it miss. So if you want to look what is the meaning of that, so you have to look at the structuring element here that you're going to use. When you want to put scan over here one by one, for example here, this one you just go put over here. So this is a considered a miss because there is nothing here match on the image itself. So if you move here, and then if you move to this particular area, right, so this is considered a fit because one of them is fit over here. So same goes to this one. You can see that here is fit on this one, right? So that what they call it fit. Any of the binary number match or overlap on the structuring elements over there, binary, the image that you want to do the morphology process. So if fit, what does it mean? Fit, it must have all fit together. For example, all this one is for example, this is all one just now, right? So it must fit like this, all this one here. And if you move to the other one, this one is also fit. So this is what they call fit. And then if there's no overlap on the image object, right? So they were going to call it a miss. So these are the three terms that you need to understand because only these two will be used as one as your erosion and another one will be used as your dilation. All right, so based on the structuring element, what you call it, the shape, and they're going to run the process and you're going to get the output of the image. Right. Okay, so we're going to learn about dilation and erosion. So what is dilation? So in dilation process, right, it will enlarge the foreground and shrinks the background. So you can see the image foreground is going to be larger. This is dilation process. So this is the input image. And erosion will shrink foreground and enlarge background. This is another process, shrink foreground and enlarge background. So you can see the background is getting bigger and the foreground image is shrinks or thinner based on the particular process. So erosion is this one, dilation is this one. All right, dilation is bigger, erosion is thinner and smaller. All right, let's look at how it does. So in dilation, right? Okay, the symbol is just like this. This is dilation. The dilation of a binary image A by a structuring element B is defined as this one. All right, this is just a mathematical representation because this is based on set, right? That's why we learned about the set theory just now. All right, so this equation is based on obtaining the reflections of B about its origin and translating shifting. Okay, this reflection by Z, then the dilation of A by B is the set of all structuring elements origin locations where the reflected and translated B overlaps with A by at least one element. This is one element, they call it hits. If one is considered yes. So you're going to work with the structuring element because this is actually a very details out of the definitions of this particular mathematical representation. So you just need to look at what happens when you do the dilation process, looking at the structuring element hits on the image. All right. So in this case, right, for example, you have the original image over here, and then you have the structuring elements over here. So remember that this would be the, normally this is going to be the origin of it, right? So what happened is basically we are going to have the first process is to have the padding here. They call it padding. Means all is going to be 0, right? So this is all 0. So this is going to be 1, 1, 1, 1, 1. So we are going to move from this one to right direction area. So if you put at this first one, right, so the origin is going to be a miss, so there is nothing lah, right? So this is like this one. So it's going to move here, move here, move here, right? So up to this layer, this is still okay, this is still 0. All right, so if you move to this one, right, so you are going to have this one, this one, this one, this one, and this one. So you have a hit down here. So this is going to be 1, which is this one. Same goes to here. When you when you have this particular process at this area, right? So let's look at this one. Here, 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 here. So there's a hit over here. So you're going to have this one. So you got this one. So in dilation process, right, is going to increase the foreground, right? You just go back this one. Dilation is going to increase the foreground by having the hits process. Hits is, remember that any of the structuring elements overlap with the object and hits any of the what I call number, uses one here and one here, then you're going to have the results on the origin of the structuring element. So in this case, the origin is at the center, so you're going to look at the results like this at the end. This is enlarging the foreground. So if you look at the result example here, the original image that you have, if you're going to use dilation 3 by 3, this is 3 by 3, right? All right, square structuring element, you can get the results like this. It's actually getting bigger, and this is even bigger if you're using the dilations by 5 times 5 structure square structuring element. So this is a structuring element you're going to use. This is example is square. This is this, right? This is just a box. It's up to this structuring element that we have. This is just example if you're using structuring element by square structuring element. This is to prove that if you're using the dilation process and hits, which is the based on the structuring elements and the object, you're going to get the results like this. Okay, let's look at the process of the dilation. Again, results here. You can see the result here is getting bigger. All right, dilation can repair intrusions and enlarge objects. Is going to enlarge this object. So this is the foreground now. It's a black color. Just now it's different, right? So this is also going to increase this one. I mean, it repair intrusion and enlarges the object. So you can see For this particular example, right, the background is white color and the foreground is black color, so it's a bit different like this, right? This is different like this. So this is foreground is black color, same goes to this one. So you can see, for example, this is just a words that actually not very good. You can see that there's actually black things or a noise over there. So when you do dilation process, right, you can see it enhance by making the words, making the what you call it, the alphabet bigger. All right, right. You can hear the difference on the dilation process after you have the input image and you have the results over here. Okay, all right. Okay, let's look at the let's look at the erosion process. All right. So in erosion process, right, it's just an opposite of the dilation process, and the symbol is like this. Just now it's a plus, this is minus, right? So this is just a representations of the mathematical in sets. Yeah. So the erosions of A by B. So you have the structuring elements and the object, right? Is the set of all structuring elements origin location where the translated B does not overlap with the background of A. So in this case, right, for structuring element, it must have a fit. Then you can get the output of the results. So if you look at the first process is to do the padding, right? So I just want to make it faster. So we just put this one instead of having the padding here, because if you put padding, right, you can see all it will be going to be 0 because there's no fits, okay, until here. The fits happens at here. When you have the structuring elements, this is a fit, and this is going to be the results here. Same goes to this one, which is this one, and same goes to this one because it's still fit. All right, same goes to, and then you get the results actually. You can see the foreground is getting thinner compared to the dilation just now. So this is a must of fit because it must fit everything, then you can get the results over here. All right, 1 if it fits and 0 otherwise. So this is used to make your foreground thinner, so you can see the erosion on the alphabet here. This is the original image. If you are using a 3 by 3 square structuring element compared to 5 by 5, of course 5 by 5 is more on the erosion. All right, so you can see this is also the results here. Okay, based on this one after erosion with this, so you can see the small lines over here, a very thin line is being reduced. At the end you can get the results based on the erosion process. So it remove the what I call the thin foregrounds over here. All right, so this is the result for erosion. And then you can see also the results over here. Based on the erosion, you also can split two objects which are connected to each other. So this is going to be smaller, and same goes to this one. You can see that this one like this. And of course, this is also going to remove and shrink the objects here. This is the object, and you're going to shrink based on this one. So based on the erosion. So it's very simple. Erosion is to reduce, and dilation is to enhance and to make it bigger. Alright, so there are two things, the dilation and the erosion. Okay, so right now, the next one we're going to learn about the compound operation, which is they call it opening and closing. So it is very simple over here because this process, opening and closing, is back related to the erosion and dilation. Alright, so for example here, if you have the closing process, right, what you need to do is from the original image, you have to dilate first and then you have to do the erosion process. This is the closing. All right. Same goes to the opening. Same goes to the opening here. First, you need to do the erosion process, and later you need to use the dilation process over here. Then you can get the opening. You can see. Let's just look at the process of closing here. From this image, is going to make a ticker right over here, and then after that, you're going to do the closing process. You can see this is a process that's going to make it like closing over here. You can see this is a closing for the process. So you can see the difference. I mean for the opening, you can see that this is actually going to open this one. Yeah, so this is actually the process of closing, and this is opening, sort of like this. All right. Okay, so in details, right, in details, this is the process of opening operations. You have this symbol, and you have this symbol first, and then you have this symbol first. So this is an erosion process first, and then after you have the image output, you are going to do the dilation process. So you can see the results from here, right? You are going to do the opening operation. So if you have this one, this is just the result based on using the SAS structure element for 10 pixels. So this is what 20 pixel structured elements. You can see it opens a small part of because it can what you call that, this opening option is to remove regions of an object that cannot contain the structuring elements, smooth object contour, you can see this is even smoother, and breaks thin connection. So this is breaking up this connection over here. All right, so this is the opening operation. Yeah, this is just another result. If you have this image, right, so for example this image, you can try to do the erosion process first by using this one. You have to do one by one. Here you get the erosion process, and after you got the output, right, you have to do again the dilation process with the same structuring element, and finally you can get these results. So there are two processes. One is erosion first, and later you have to do the dilation process. From this input image, you're going to get this image over here. All right. So same goes to closing operations. So this is the closing operation. This is a dot, dot. Just now it's just a small dot over here. So the symbol will be like this, and this process actually opposite to the other one just now. The closing process is dilation process first, and then you're going to do the erosion process. Neither the same, but different method first. All right. So what does it do? Okay, the closing operation fills holes that are smaller than the structuring elements, join narrow breaks, fill gaps in contour, and smoothest object contour. So you can see here the result from this original version. All right. So this is being removed, right? This one, and this is also being removed because it's a small version of this one. Right, so this is consider the foreground, right? Something like this is a background here. Here this is a foreground, so you can see that this is being removed. All right, this is, and also smoothest object contours. This is smoothing the object contours over here. All right, so this is also the same example. You can see if you are using this structuring element, you do the dilation process first, and then from the result you do the erosion process. Finally you can get these results. You have to try by yourself one by one, because the questions that I'm going to ask, we are going to do that one again based on the other input image. All right, so you can try to do that one, and then this is just the example again. You can see how we are using these techniques of closing and opening process to enhance or to improve the image from the noise that we have. So this is actually the original input image. You can see small white pixels over there. So when you do this particular process, right, and then this is A minus B. Minus is actually the dilation, is it correct? Erosion, sorry. A minus B is erosion. Right, this is erosion by using these particular structuring elements, and then after that it dilates, and then this is a process that you get, right? So you can see this is the results one by one. Okay, this is a process, and this is just the mathematical representation of it, and then this is just the example that we have just now. If you are using the process of opening and closing, all right, if just now this is just the opening and this is going to be combinations. All right, we learned about the closing opening just now, so this is a combination. You're still using both closing and opening process. You close first and opening process, so you're going to use four process, which is based on dilation, erosion, then erosion, dilation. This is based on the closing and opening, right? So this is the results. If you use the results here to remove a noise, original here, result after opening is, and then result after closing. This is combination, eh? So you're going to see the result based on combinations is getting better. All right, so in this topic we just learned about the process of morphological process, and we learn about just a very simple algorithm, which is the morphology process, the dilation and erosion, and this is being used more than once, and you can see the results like this to improvise the image that you have. All right, so that's all for the lecture, and you're going to uh, look at the questions in the quiz will be posted later. Thank you.